be solving Math Applications SL, Paper 2, May 21, Time Zone 1. Let's get started. Question number 1. As part of his mathematics exploration about classic books, Jason investigated the time taken by students in his school to read the book The Old Man and the Sea. He collected his data by stopping and asking students in the school corridor until he reached his target of 10 students from each of the literature classes in his school. So he didn't ask any random students. He asked only students of literature class who studying literature, and he didn't ask also any number of students. He asked specifically 10 students from each class. So A, state which of the two sampling methods, systematic or quota, Jason has used. So this will be a quota sampling because this is the meaning of quota, that he specifically asked 10 students, exactly 10 students from each class. It is not random sample. He didn't ask any random student at school, or even he didn't create a systematic method. He took portion of classes, 10 students from each class. So this is what quota means. Jason constructed the following box and whisker diagram to show the number of hours students in the sample took to read this book. So we know that in the box and whisker, this is the minimum. The minimum here is 5. This is the maximum. And this line in the middle, this is the median here. And this is Q1. This is Q3. Lower quartile and upper quartile. So these the information that we need to recognize in this box and whisker diagram. B, write down the median time to read the book. So the median time is 10 hours. C, calculate the interquartile range. So what is the interquartile range? This is Q3 minus Q1. So here we need to identify, interquartile range is Q3 minus Q1. And here we can clearly see that Q3 is 15 minus Q1. Here we must notice that between 5 and 10 there are 10 boxes, means that each two small boxes here, this is 1 hour. So if this is 5, this will be 6, and this will be 7. So Q1 is exactly 7. 15 minus 7, this is 8. So this is our interquartile range. Mackenzie, a member of the sample, took 25 hours to read the novel. Jason believes Mackenzie's time is not an outlier. Determine whether Jason is correct. Support your reasoning. So to identify the outlier, we need to find the boundary. So we have upper boundary and lower boundary. Upper boundary, this is if the number is above the maximum, this is upper boundary, and if it's below the minimum, so this will be a lower boundary. And here we are talking about 25 hours. So this is in the upper boundary. So how we would calculate the upper boundary? So upper boundary is Q3, here in the upper part, so we're using the Q3 plus 1.5 times interquartile range. Means that the upper boundary is 15. This is our Q3 plus 1.5 times 8. If we will calculate this, we will find it's a 27. Means this is the upper boundary. This is the maximum. Any number above 27 will be considered as an outlier. And because here 25 hours, this is Mackenzie's time, is less than, so 25 is less than 27, the boundary, the upper boundary, so Jason is correct. Jason is correct. So we're writing Jason is correct because 25 is less than 27, which is the upper boundary. This is D. For each student interviewed, Jason recorded the time taken to read The Old Man and the Sea, X, measured in hours, so X is the time measured in hours, and paired this with their percentage score on the final exam, Y. So X here in this diagram represent the time in hours, Y here represent the percentage in the exam. These data are represented on the scatter diagram. Here it is. Describe the correlation. The first, we can notice that it's the correlation, or these dots here, the scatter diagram is going down, which means it's a negative correlation. The point is, here all the dots very close to each other, but here there is some gaps, some distance between the dots. So we cannot identify clearly if it's weak or if it's a strong correlation. So all what we need to identify, all what we need to write here, it's negative correlation. You may write, okay, it's a strong or moderate, but this will not be taken in consideration because we cannot identify clearly without a value, without the number, the R, the correlation coefficient. So here, all what we need is negative correlation. Then, Jason correctly calculates the equation of the regression line y on x for these students to be y equals negative 1.54x plus 98.8. He uses the equation to estimate the percentage score on the final exam for a student who read the book in 1.5 hours. So he will use this equation to find the percentage. This is the y, percentage score, and the time, this is the x. Find the percentage score calculated by Jason. So we are substituting x with 1.5, y equals negative 1.54. Instead of x, this is 1.5 plus 98.8. So this is 96.49, which is three significant figures, will be 96.5%. This is F. G, state whether it is valid to use the regression line y on x for Jason's estimate. Give a reason for your answer. So, to decide if it's valid or not, reliable or not, we must check the number that we used here to substitute, 1.5. And we must compare it with the values that we have in the scatter diagram. Here in the scatter diagram, we can see that the least number here is approximately 5 hours. And we are using 1.5. And we calculating for 1.5. 1.5 is a little bit far from the minimum value that we have. Again, he used these dots, he used these values to find the equation. And if we are using this equation to estimate some other values, we must consider this data range. This data range means that x from 5 till here we can say that it's a 25. So if you are using this data, if you are using this equation within this data range, okay, so this is a good estimate, this is correct estimate, valid estimate. But if you are using the equation to estimate a value out of the data range, so this is not valid. Okay, if we are starting from 5 and you are using 4, this could be correct. Yes, it's valid. But here, 1.5 is far from 5. The maximum here is 25. If you are using 30, if you are substituting 30, also this will not be valid. If you are substituting 26, okay, fine, it's close to the data range. But using a number to substitute out of the data range, this will make the estimate is not valid. So here, state whether it is valid. No, it is not valid. And whenever we're saying it is not valid, because it is out of outside, we can say outside the data range. The data range given. Okay, so this is the reason. And here let me highlight, if you will not write the reason, if you are not writing because it's outside the data range, out of the data range, your answer not valid will not be considered. If you are not writing a reason, you will not get a point for this not valid. Writing just not valid or even valid, any of the answers will not be considered without a reason. Then Jason found a website that rated the top 50 classic books. He randomly chose 8 of these classic books and recorded the number of pages. For example, book H is rated 44th and has 281 pages. So here, number of pages, and here is the rank. So this book H has 281 pages. This is the rank 44. This is shown in the table. So we have book A, B, C, D, E, F, G, H, number of pages, and the rank. Jason, instead of intended to analyze the data using Spearman's rank correlation coefficient R. Copy and complete the information in the following table. So here we need to organize these values. Organize here means we need to write the rank, the order. So it's written here, A is rank number 1. A here, the rank number 1. Means that we are starting from the largest number of pages. So this is 1, largest. and the following will be D. This is number 2. Then we have here 863. This is number 3. Number 4 would be 600. 585. This is rank number 5. Then E. Then H. This is 7. F. This is 8. So this is the rank or the order of the number of pages. So here is 1, 3, 5, 2, 6, 8, 4, 7. And also we will do the same for the rating of the 50 rating, top 50. A is 1. So this is number 2. 5, it's already in order. So 5, 7, 13, 22, 40, 44, it's already written in order. So 1, 2, 3, 4, 5, 6, 7, 8. So this is the table. Now calculate the value of R. Again, correlation coefficient, but this time using this table. So what we will do is we will insert into stats in our graphing calculator. We will insert this row as our first column and this row as our second column. So this will be L1, this is L2, 1, 3, 5, 2, 6, and so on. Here 1, 2, 3, 4, 5, and so on. And then you will press calculate regression line reg. And when you press line reg or regression line to calculate the regression line, you will be given the equation and you will get R. And you will find R in your calculator 0.714. So again, you are pressing stats, insert the values, then calc regression line reg, and in some graphing calculators you will be asked for which form of the regression line. This is AX plus B. This is what we are using, AX plus B, and you will get value of A, value of B, then R. R is 0.714. Interpret your result. So this 0.714, obviously it's positive. So first, it is positive, and this 0.7 could be considered as moderate. You may write a strong, both will be correct. It is not very strong. You may write strong or moderate. So positive, moderate correlation. Between the number of pages and the top 50 rating. So this was the first question in this paper, and I will be waiting for all your questions on the Facebook page, Instagram, Twitter. You will find all the links in the description box, and see you next video. Goodbye.